So good afternoon, friends. In today's video, I'm gonna talk about the problem called threesome closest. So, friends, in this video, I'm gonna explain the solution from this page, and actually, I'm gonna talk about the thought process or the intuition behind the solving this particular problem. So, actually, this is the extension of the problem called threesome. So, if you solve that particular problem, that's fine, and if you haven't solved, still you can uh, go with this particular solution because I'm gonna talk about the solution uh, directly from the sketch. So if after watching this particular solution, actually you'll able to understand, you'll able to solve this threesome problem as well. And the main intuition of there is a parent problem called twosome. So for all of these problems called threesome closest as well as threesome, the parent problem is twosome. So if you know the twosome, that's fine. Actually, in this problem and in the threesome problem also, you'll have to use the concept which is used in twosome problem. So twosome problem is based on sorting as well as two-pointer technique. So let me first explain what the twosome problem is actually, and I'll talk about that. What is the thought process behind the twosome problem, and how do we optimize that particular n square solution to the n log n solution by making use of sorting in case of two pointer. So let's say I have some elements. So let's say I have the element 1 and 5, and let's say this is 7, 9, and 4. And what the two sum problem statement is, you are given a target. So you would be given a target. So let's say, let us take some different target over here. So let's say the target is what? The target is 11. So the problem statement of two sum is, you have to figure out such a pair in this particular array whose sum is add up to this 11, right? So you have to find a pair whose sum is equals to 11. So what could be the brute force solution? So the simple brute force solution is to check all possible pairs. So there are obviously total n C2 pairs. So what you could have done, you can just figure out, or you can just explore all the possible pairs, and you're gonna get any such pairs whose sum would be equal to the given target. Then that would be your answer, and that would be obviously the order of n square approach. So what you would have done, you will make use of one outer for loop. So int I is equals to, let's say, 0, and this will go till I is lesser than n and I plus plus. So you will have one inner for loop. So inner for loop will run, let's say, int j is equals to I plus 1 just next to it, and j would be lesser than n and j plus plus. So now here what you have to check, you just have to check if your let's say ARR of I plus ARR I plus ARR j is equals to, if it is equals to your given target, then what you need to do, you can just return that yes, this pair exists. So you can just return true, right? And finally, if doesn't exist, you'll finally will be returning false over here. So this is the simplest solution which you can solve this in order of n square. So now you can optimize this particular solution to the order of n log n solution. So in that particular solution, what you do, you just first sort all the elements, and after sorting, you just apply the two pointer technique. So what you do, you just sort out these all the elements. So after sorting, what you're gonna get? You're gonna get 1, and then 4, and then 5, then 7, then 9, and your obviously the target is still 11. Now you have to find such a pair whose sum is equals to 11. So now how do you apply the two pointer technique over here? So what you do, you just take two pointers. Let's say this is I and this is J, right? So you'll be starting, one of the pointer will be the front of the array, and the another would be the last element of the array. So you just add up these elements. What you are getting 10. So 10 is obviously lesser than 11. Fine. So if 10 is lesser than 11, So it means you want to get the greater value, or you want a pair whose sum is greater than 10. So that's why what you do, like what you do, if you just decrease this j, then you know the value to the left side of this pointer j, left side of this particular value 9 would be lesser than this. So that's why you will not able to get a pair uh, whose sum is greater than the 10. So there is no use of just decreasing this particular right now at this point of stage. There's no need of decreasing this pointer j, because you want to get a pair which whose sum is greater than this 10. So what you do, you just increase this g I. So obviously, what you can eliminate, you can eliminate, because this I, this one, will never able to contribute in a pair whose sum is equal to 11, because you have added that particular one to the greatest value, which is 9, and still you are getting the values is lesser than 11. That's why this one will never gonna contribute in your answer. That's why you just increase this I by 1, and now your I will be pointing over here. So now what can happen? You can just see that now you are getting the sum which is equals to 13, and obviously you can understand 13 is greater than 11. Now what you can understand the value, since this summation is 13, so you can just see ki if for this particular 9, if you see all the elements which is right hand side of this 4, those are greater than 4. So obviously this 9, if this will add up with these values, so you're gonna get the sum which is greater than 13. So that's why you'll never able to get the sum 11, because all these are greater than 13, greater than 13, yeah, greater than 11. So that's why in this case you can eliminate this 9. You can eliminate this 9, because your this 9 will now forward, your 9 will not gonna contribute in any of the answer. So that's why you'll decrease j by 1, and here you will be here. So now when you will add up, you are getting what? You are getting 7 and 4, which is equals to uh, 11, right? Yeah. So 7 and 4 is equals to 11. So what you are getting? So obviously 7 and 4 is equals to 11, and your target is 11. So in this way you got your answer, and finally from here only you will gonna return true, because you got a pair whose summation is equals to 11. So in this way you have to make use of this two pointer technique to solve the two sum problem. So the same approach, I mean the same two pointer techniques we're gonna use in this three sum problem as well, three sum project. So now actually here we have to select two element only, right? But in this problem what we have to select, we have to select three element. What we have to select, we have to select three element. So now how we can decompose this problem to the two pointer problem? So let's say, that's fine. Like let's say if I have chosen one element I have already chosen, right? If one element I have already chosen, what else I have to do? Obviously, I have to figure out two elements now, right now, because after choosing one element, I can just say ki I have to figure out now two elements. So on those two elements, like initially there was your target, like let me say still your target is equals to let's say in this case your target is 10, right? So if your target is 10 and you have chosen 7 right now, so what would be the your new target? Your newer target, because you have chosen one element, so your new target would be your actual target minus the current element chosen. So your actual target was 10. So 10 minus 7 is what? 3. So now you have to apply two pointer technique on this particular new target called 3. So now you'll look here whether you'll able to get 3 or not. And if you'll able to get 3, that's fine. And yeah, so in this way, since you can see that there's no pair whose sum is equals to 3, so that's fine. So in this case, you'll now this element you have chosen, now you will try for the second element. Now you will choose this element, and now you will see that whether such kind of pair exists or not. Right? Like in this case, you are choosing one. So before this, obviously you'll have to sort all these elements. I have to sort for this obviously, because you cannot apply the two pointer technique without sorting. You cannot apply. So first you'll sort these elements, and then obviously you're gonna apply. So in this case, what you could have done key, if you have selected this, finally at the end you'll be getting this 5 and 4, 9, and this would be equal to 10. So in this case also you're gonna get a triplet whose sum is equals to 10. Now actually this problem is all about threesome. Now, this is a very small variation of this problem, very small, which is called closest, right? So in this threesome closest, you have what you have to do. There is no need to find the exact target. The sum which you need to find that is not necessarily to be equal to the given target. You just have to find that is as much as closest. So it could be equal to the target as well, and it could be uh, anywhere. It could be greater than that, it could be lesser than that, but you have to figure out such a triplet whose sum is as much as closest. So what do you mean? What do you mean by as much as closest? So if you have some value, let's say if you have right now only you have the target 10, and let's say if you are getting some values, some answers you are getting, let's say one of the target you are getting 8 and one of getting 11. So which value is closer to this 10? How you can figure it out? Let's say one another value called 10 is also there. So if you, how you can figure out? So if you will take on number line, if you'll represent, so you'll able to figure out. So if you will take the absolute difference between all the values, so let's say the absolute difference between this is 2. So here, what other things I'll need? I'll need the difference. So initially I'm taking my difference as int max. Let's say this that is a very far away from my target. And finally I'll be taking one answer. So I'll the answer, the final answer, the sum I'll get, I'll gonna store into this answer variable. So here int I is equals to 0 and I is less than n, and I is I plus plus. So here this for loop will be choosing the outer elements, the one element, and then rest of the element I'm gonna apply the 2 pointer technique. So my new target would be, as I said, that would be nums of target minus nums of I, yeah, and int j is equals to I plus 1 and k is equals to n minus 1. Now I have to apply the 2 pointer technique on this rest rest number of elements. So here I'll check that if nums of I, nums of j plus nums of k is, let's say, exactly equal to your new target. If this is exactly equal to your new target, then it means you get such a triplet whose sum is actually to your given target. So here in this case you can directly return. There is no need because this is as much as near as possible. Since absolute difference will gonna be equal to 0, so now there would be no other pair which would be as much as near, because this is exactly equal to the given target only. So here you will be gonna do this, and now what you will check, if your difference is greater than the uh, absolute of nums of I plus nums of j plus nums of k minus your actual target. If it is, if your this difference is greater than uh, the selected triplet, then what you will do, you'll just update your you're gonna update your difference to yeah, you're gonna update to the new difference over here. And in this case, since this is the beta answer which we are getting, so that's why what you will do here, you will store your new answer over here in your answer variable. Yeah, and finally, what you will check, if your nums of j plus nums of k is greater than your new target, then what you will do, since this is greater than your new target, so you want lesser value, so you'll just decrease your k by 1, and if it is not the case, then you'll just increase your j by 1, and finally what you'll do, you'll be returning the answer. So hope this is clear. The approach which I explained, I just coded over here. So if I'll run this solution, let me run this. Yeah, so let me submit this. So yeah, it's accepted. So hope this is clear. And actually I just want to mention that I have created one of the post over here as well. So I'll be mentioning the link of this in the description of this video. So if you want to read out this particular article, this is the same here. I have explained. Actually, I have given the code as well. You can see the Python code. You can see the C++ code. Everything I have given here. So if you want to see the post, also you can check out the description. So thank you so much. Finally, thank you so much for watching this video. And if you like this video, do subscribe to my channel if you are new to my channel, and share with your friends and like the video. And we'll meet in the next video. Thank you so much.